Alright, we have a no heat call today. I just got on the roof, so I want to do the service call from start to end. Just the process of, troubleshooting. Did the simplest thing first. Both those units' thermostats are calling. They're on heat. Did find one problem right straight off, and it's a design issue. So this is a makeup air. So this is designed to put all the air back into the building that exhaust takes out. Problem with this setup is you can see this is unconditioned, which is fine. Usually when they do unconditioned makeup airs, they have the vents for it angled up towards the exhaust, so the cold air will come right into the building and go right back out. Well, not so with this one. With this one, the vents are right over where the cooks are standing on the cook line, so they're freezing their ass off. The only problem is with shutting that off. If I don't, I might not. So there is a hot water tank, which I'm assuming that one is theirs. Either that one or that one. Probably doesn't have a powered vent exhaust. So if I do shut this off, I have to make sure that the building isn't under too much of a negative draft to let those hot water tanks exhaust. This is part of a little strip mall, so it might not be as critical as if this was a single standalone building, but something I'll have to check. So let's hit the first one. So this is the kitchen unit, I'm assuming back of house. Alright, this one is running, so that's not our problem. The kitchen is probably cold from a combo of the front unit not running and that sucker dumping in ice cold air. This front one here, this is not running. Alright, so this air is cold. So that means, it's actually not as cold as outside, but that just might be sucking warming the air from the heat exchanger itself out. I don't think this one actually fired. So, fortunately I forgot my tripod. So what I'm going to do is leave the disconnect and everything on and take off this access panel here, and we'll see if we have a code. Now they look like either Carriers or Bryant's. So it's a Carrier, so it should have a flash code inside there. So let me go ahead and take this one off. Alright, so I got the panel off. Quick visual inspection of a normal Carrier trait is this wall here rotting out. And a little rust mark on that screw. You can see it back there. Right about there, but it's not all the way through. The wall doesn't look bad. That coil needs to be cleaned though. A lot of people with these little 5-ton Carriers, just be aware. You can see the outside coil doesn't look that bad. So somebody's been cleaning this, but only the outside panel, outside part of the coil, not realizing that it wraps around on the inside also. Extremely common problem. A lot of people don't realize that the coil is actually hidden behind that electrical panel. So I got this electrical panel off here. There is a little LED light right there. I don't know if you guys the camera can pick that up flashing. It's kind of dim, but let's see. 1, 2, 3, 4 flash. 1, 2, 3, 4. All right, 4 flashes. So we go to our little cheat sheet right here. 4 flashes. 4 consecutive limit switch faults. So either my limit switch itself is dead, or they had the belt is limit switch. Few things that could happen with that. Limit switch itself could be bad. They could have had the thermostat cranked to like 90 degrees, which when I got here was set at 68, so I'm assuming that's not a problem. Belt could be off, or blower motor dead, so not moving any airflow over that heat exchanger, or the filters will be clogged, which is basically the same thing, no airflow over the heat exchanger. So first thing, I'm going to take this panel off. I'm not going to reset the unit. I'm going to take that off. I'm going to check the motor, the belt, and then we'll check the filters, and then we'll check the limit switch. Okay, so motor's good, belt is loose, blower's going pretty slow. Should be somewhere in that range of speed. filters look absolutely horrible. So those are going to get pulled. So we do have a low airflow condition. That's more than likely our problem, but our limit switch is right here. And I'm going to take my meter and go across it real quick and see if it's closed or open. There's actually, there's an old one right here. So that's been replaced at some point. So we're going to check this one and make sure it's good. So now I can shut the unit off, and all you got to do is take this little screw out here. This little protector comes off. This is so if this belt breaks, this belt doesn't come back around and whip this. Take this off and check between those terminals. Okay, so I'm ready to check this limit switch. It's going to pull these two wires off just to make sure that if we were to check these two here, make sure every other switch in the circuit here, actually the centrifugal switch is going to be closed, so that isn't going to do anything. So I'm going to check this, and we have continuity there. So my switch is not, I mean, doesn't necessarily mean that there isn't a weak switch, but more than likely the switch is perfectly fine. We'll leave that sucker alone. See, the biggest problem is you'll get a lot of people that will read those codes and it'll tell you what to do, or to tell you what's wrong or what it's off on for a code, what switch is off, or you know what's wrong with the unit relatively, and they'll go right to that part and replace that part and not figure out the cause of it. So if you were to just go ahead and replace this part, yeah, it'll probably run while you're here for the 10 minutes watching it, but as that heats up, that's going to trip, because we're not getting any airflow. So you have to go to the, heart of the matter, basically. So what I'm going to do too is I don't need to take this entire panel off to check the heat exchanger, really. I just need to take this outside panel off here. It's easier to see the bends at the end, and that's usually where they're going to break. Judging by that inside wall, we're not going to have an issue with it, but because we're here and because I want to be thorough, we're going to take a look at the condition of the heat exchanger. Okay, so here's the heat exchanger coil bends. Usually most carriers, where they're going to break is going to be right here at the very bottom of the first set of burners, or split right along the seam that's on the side. And these are perfectly fine, so I can put that panel back on. And just to show you, here is one of the air filters. Now, if I hold it up to the sun there, you can see light through it, so it is getting some air, but that's pretty terrible. So those are going bye-bye. I don't have any in my truck, but I'll just pull them out for now and then sneak by here either later on today or tomorrow morning, pop new ones in. I'll do both of them. So right now I'm gonna replace that belt. I'm actually gonna check the belt on that one too while I'm here, and then we'll go from there. Okay, so here's the old belt. Got an AX38. The only thing I have in my truck that perfectly matches that I wouldn't have to adjust is a 4L400. Now, usually 4L or A belt are run 2 sizes smaller than a 4L. So you see this is a A38. You need a 4L400. Now, the difference between them, you consider the 4L series a light duty belt. A series look exactly like this. They're a heavier duty belt. Kind of consider those like a standard duty. And then an X is a tooth belt. These last a long time. Now, you guys can tell me you're blue in the face that you can't use a 4L in place of an A series belt because of the horsepower rating. This is only half a horse motor here, turning this little rinky-dink blower. Yeah, it's not going to last as long, but as long as they keep up with their PMs, which I'm going to recommend they do, considering that, you're perfectly fine with this. So I'm going to put this on, and then we're going to start it up, and we can measure our amperage. If you do have to adjust this belt, there's a screw here, and there's one all the way in the back there, and that whole plate slides up and down. So we got a whole party on the roof here today. There's another company working on one of the other units, so if you hear noises in the background, that's why. So let me put this on and we can start her up. Okay, so we're ready to go. When you test an amperage on your motor, put all your panels back on so it's sucking the air from where it should be and you're getting a true amperage reading. We should be reading our full load on the motor should be 5.6 to 5.8, somewhere in that neighborhood. Should be good. So first thing that'll happen, there might be a delay because those are digital thermostats, but once we get the call for cooling, or heating rather, this draft motor will turn on. Then once it sends a signal from this Hall effect sensor right here to the board, at that motor's turning, it'll turn on. So right now my blower's on. I'm reading 2 amps, so we're good and we're nice and tight. Just fired. Everything's looking good, so I'm gonna let this one run. I'll pull the filters, check the belt on that one, go from there. So this is the other unit, and although it's running, that belt is loose. I also just noticed some loveliness. So rather than pulling 2 thermostat wires through the building, they pulled 2 up into this unit and along the inside of the blower section through that piece of liquid tight and into the other unit. That's cute. Alright, I can change this belt too. Whew, a little cold. So everything's all set with those 2 units. Main problem was obviously poor airflow. So both those units are up and running. They've been running for 15-20 minutes. I'm happy with that. I did a little bit of investigating downstairs and checked around for their hot water tank. So some places hot water tanks can be in like an outside closet, but theirs is in the cellar, and right next to it on the other side of the wall is an office. So there are people down there. There's also a walk-in down there. So there are people down there. And the hot water tank does not have a draft inducer on it. So while it probably will be okay if I do shut that makeup air unit off, I didn't design it for them and I didn't sell it to them, and I am not taking the liability of shutting it off and having that hot water tank backdraft down into that basement and pour carbon monoxide down there. So that's staying on. There's nothing I can do about that. Again, kind of a crappy design. Usually when they dump the makeup air in on the line itself, usually it's preheated, and even those preheats really don't last a long time. They break down, they rot out really quickly. Most of them will have the cold air or the pure outside air dumped in the flow of the actual exhaust unit, so you're not getting all that cold air in your restaurant, which obviously this isn't the way they did that. So nothing I can do about that. Unfortunately, they'll just kind of have to live with it for now. What they did do is kind of build a little bit of a deflector on the front of it with some sheet metal to deflect the air up and over and around where the people stand, so it comes in behind them. It's actually the whole face of the actual makeup air hood is where the lines come in, so it's not like you can take a duct and move it. It's all hard piped into that entire exhaust hood, which is something that I am not going to touch. So besides that, this call is done and we are on to the next one.